In September 2025, NASA published a peer-reviewed paper in the journal Nature that sent a genuine wave of excitement and, for some people, genuine unease through the entire scientific community. Buried inside a reddish, arrowhead-shaped rock on Mars, a rock nicknamed Chiava Falls, scientists had found something they were calling the closest evidence humanity has ever come across, suggesting that life might once have existed beyond Earth. The rock contained strange, colorful mineral patterns, features scientists nicknamed leopard spots, carrying the chemical fingerprints of processes that, here on Earth, are almost always associated with microbial activity. NASA was careful, as good scientists always are, not to declare that life had definitively been found. But the language used by NASA's own leadership was striking. This was described as the closest humanity has ever come to discovering life on Mars. In this video, we're going to dig deep into exactly what NASA's Perseverance rover found beneath the surface of the red planet, why this particular discovery has scientists so genuinely excited and cautious at the same time, and what it might mean if we really are looking at the first tangible evidence of ancient life on another world. To understand why this discovery matters so much, you first need to understand where it was found and why that location was chosen in the first place. Perseverance, NASA's most advanced Mars rover, landed inside Jezero Crater back in February 2021, a location carefully selected by mission scientists specifically because billions of years ago it was almost certainly filled with water. Orbital imagery collected over the preceding decades had revealed unmistakable evidence of an ancient river delta spilling into Jezero Crater, the kind of fan-shaped sediment deposit that forms here on Earth wherever a river empties into a lake or sea. This meant Jezero Crater was once a genuine Martian lake, fed by a river system carving its way through the surrounding landscape, and on Earth, this exact kind of environment, a quiet, sediment-rich lake bed fed by flowing water, is precisely the kind of place where microbial life tends to thrive, and where the chemical traces of that life tend to get preserved for extraordinarily long periods of time, sometimes for billions of years, locked away within layers of fine-grained mud and clay. In July 2024, while exploring a rocky outcrop system known as the Bright Angel Formation, located along the edges of an ancient river valley called Neretva Vallis, that once carried water directly into Jezero Crater, Perseverance came across an unusual arrowhead-shaped rock roughly 3 feet by 2 feet in size. Mission scientists nicknamed it Chiava Falls, and almost immediately, the rover's instruments began picking up on features that made this particular rock stand out from everything else the mission had studied up to that point. The rock's texture and composition, made up of clay and silt, was exactly the kind of fine-grained sedimentary material known here on Earth to be an excellent preserver of ancient microbial evidence, precisely the type of material the entire Perseverance mission had been specifically designed and sent to Mars to find. As the rover's Sherlock instrument, an acronym standing for Scanning Habitable Environments, with Raman and luminescence for organics and chemicals, began analyzing the rock surface in more detail, it detected the presence of organic molecules woven throughout the material, carbon-based compounds that represent one of the fundamental chemical building blocks associated with life as we understand it. Organic molecules alone aren't proof of biology. They can form through purely non-biological chemical processes too, and Mars has produced plenty of organic material through such processes throughout its long history. But their presence within a rock this promising, formed in an environment this water-rich, was enough for the mission team to recognize that Chiava Falls deserved much closer attention. As mission scientist Ken Williford would later put it, discovering organic-bearing fine-grained rock exactly matching what the team had traveled to Jezero Crater, specifically hoping to find felt like validation of years of careful mission planning finally paying off. It was when Perseverance's cameras captured higher-resolution images of the rock's surface that things became genuinely strange. Scattered across Chayava Falls, scientists spotted a series of small, distinctive, dark-rimmed spots, features the team informally nicknamed poppy seeds, alongside larger, more complex circular patterns they came to call leopard spots, owing to their visual resemblance to the distinctive markings found on a leopard's coat. These weren't random blemishes or simple discoloration. They displayed a clear, structured pattern, dark rims surrounding lighter, bleached-out centers, arranged in a way that suggested something specific and chemically meaningful had happened at these precise locations within the rock, millions or billions of years in the past. To understand exactly what these leopard spots represented, Perseverance's mission team turned to one of the rover's most sophisticated instruments, PIXL, short for Planetary Instrument for X-ray Lithochemistry, a device capable of mapping the precise chemical and mineral composition of a rock surface in extraordinarily fine detail. What PXL's data revealed was remarkable. The dark rims surrounding each leopard spot were rich in a mineral called vivianite, a hydrated iron phosphate compound that, here on Earth, forms commonly as a byproduct of microbial activity occurring within oxygen-poor sediments, the kind of muddy, waterlogged environments where certain types of bacteria thrive by exploiting chemical reactions involving iron. And at the very center of each leopard spot, nestled within the bleached, lighter-colored core, PIXL detected a second mineral, greigite, an iron sulfide compound that, on Earth, can also form through microbial processes, specifically through certain types of bacteria capable of cycling sulfur as part of their metabolism, though scientists are careful to note that greigite can occasionally form through non-biological chemical pathways as well. According to Joel Hurowitz, Associate Professor of Geosciences at Stony Brook University, Deputy Principal Investigator of the PIXL instrument, and lead author of the Nature paper detailing these findings, the structure of the leopard spots revealed something like a chemical stratigraphy, layered zones of different minerals radiating outward from the center of each spot, each one representing a different stage of the same underlying chemical reaction. Hurowitz explained that the original material forming this rock would have been a rusty reddish mud, rich in oxidized or ferric iron, the same basic chemistry responsible for the reddish color found across much of the Martian surface. But at each leopard spot, something had triggered a chemical reaction that stripped this reddish iron out of the rock's core, transporting it outward and converting it into these new mineral phases. Vivianite along the rim and greigite concentrated at the very center. In some locations nearby at an abrasion patch the team nicknamed Apollo Temple, this bleaching reaction had proceeded so completely that the rock's characteristic reddish color had been almost entirely removed, suggesting an unusually large supply of organic material had been available to drive the reaction to its fullest possible extent at that particular spot. Poor environments make their living by using iron and sulfur compounds, essentially the way we use oxygen, moving electrons between different chemical species as part of their basic metabolism, and in the process, they leave behind exactly this kind of mineral fingerprint, iron phosphates and iron sulfides forming in close proximity to whatever organic material the microbes were feeding on. Seeing this same distinctive pattern preserved within a 3.5 billion-year-old Martian rock, formed in an environment that once genuinely held liquid water, was enough for NASA's scientists to formally classify Chayava Falls as containing what's known as a potential biosignature, a substance or structure that might have a biological origin, but which requires additional study before scientists can conclusively determine whether life, or some far more mundane, purely chemical process, is actually responsible for creating it. It's genuinely important to understand exactly what that phrase, potential biosignature, does and doesn't mean, because it represents one of the most carefully worded, deliberately cautious statements in recent NASA history. NASA was explicit and consistent in stating that this discovery does not prove that life once existed on Mars. Both vivianite and greigite, while commonly associated with biological processes here on Earth, can also form through entirely non-biological, purely chemical pathways under the right conditions, without any involvement of living organisms whatsoever. Scientists studying the Chayava Falls sample have specifically noted that non-living abiotic chemistry remains a real scientifically plausible explanation that cannot yet be ruled out. What makes this discovery so significant isn't that it constitutes definitive proof of ancient Martian life. It's that the specific combination of features found together in this rock, organic carbon, iron-sulfur mineral associations, and reaction front patterns matching biological signatures observed on Earth, represents the strongest, most compelling case for a potential biosignature that any Mars mission has ever documented in the entire history of exploring the Red Planet. Given how significant this finding is, NASA's leadership didn't hold back in describing its importance. Acting NASA Administrator Sean Duffy stated publicly that this discovery represents the closest humanity has ever come to discovering life on Mars, calling the identification of a potential biosignature on the Red Planet a genuinely groundbreaking result. Nikki Fox, NASA's Associate Administrator for the Science Mission Directorate, emphasized that this finding was the direct result of years of careful strategic planning, describing it as validation of the entire approach behind sending Perseverance specifically to search for exactly this kind of evidence within Jezero Crater's ancient lakebed sediments. This kind of confident, celebratory language from senior NASA officials, while still carefully qualified with appropriate scientific caution about what remains unproven, reflects just how significant this particular discovery is considered within the broader scientific community studying the search for life beyond Earth. Once the mission team recognized just how scientifically valuable Chayava Falls appeared to be, they made the decision to use one of Perseverance's limited and precious sample collection tubes to drill directly into the rock and extract a solid core sample, a sample now formally designated Sapphire Canyon. This decision carried real weight, because Perseverance carries only a limited number of these specialized sample tubes, and each one represents a permanent, irreversible commitment, given that these samples are intended to eventually be returned to Earth for far more detailed laboratory analysis than any instrument currently on Mars could ever perform. The fact that mission scientists chose to spend one of these precious sample slots on Chayava Falls speaks volumes about how significant they judged this particular rock to be, even before the full scope of its leopard spot chemistry had been fully analyzed and understood. This raises an obvious and important question: what happens next, and how might scientists ever move from potential biosignature to something more definitive? The honest answer is that truly confirming or ruling out a biological origin for the leopard spots will likely require analysis using instruments and techniques far more sophisticated than anything currently available on Mars itself, no matter how advanced Perseverance's onboard suite of instruments genuinely is. This is precisely why the Sapphire Canyon sample, along with dozens of other carefully selected samples Perseverance has collected throughout its mission, is intended to eventually be returned to Earth as part of NASA's larger Mars sample return program, allowing scientists here on Earth to study this material using the full power of modern laboratory equipment, techniques capable of detecting far more subtle chemical and structural details than any rover instrument, however advanced, could ever manage while operating remotely on another planet tens of millions of miles away. It's also worth taking a closer look at exactly how scientists went about distinguishing whether these leopard spot patterns actually formed in place directly within the rock as it originally existed, versus the possibility that they might simply represent material deposited from somewhere else entirely. This distinction matters enormously because a feature that formed through some kind of external deposition process would carry a very different, far less compelling scientific story than a genuine reaction front that formed directly within the original sediment as it was first being laid down. Urowitz and his research team worked through this question carefully, reasoning that if the leopard spots had instead been created by material transported in from outside the rock, seeping in through cracks or fractures after the original sediment had already solidified, the resulting mineral pattern would likely look noticeably different, more concentrated along specific fracture pathways, rather than distributed as the roughly spherical, evenly structured reaction fronts researchers actually observed spreading outward from small, discrete points within the rock. The consistency and symmetry of the leopard spot patterns appearing repeatedly at multiple different locations across the rock's surface, each with the same basic dark rim, bleached core structure, strongly supported the conclusion that these features formed through an in-place chemical reaction occurring within the sediment itself, precisely the kind of process associated with either genuine ancient biology or some equally interesting, if less biologically significant, abiotic chemical process operating under the right specific conditions. Given how much scientific weight rests on eventually distinguishing between these biological and non-biological explanations, it's also worth understanding exactly why Mars sample return matters so enormously to this entire story. Perseverance's onboard instruments, remarkable as they genuinely are, still represent a relatively limited toolkit compared to the vast array of specialized equipment available within terrestrial research laboratories here on Earth. This is precisely why, despite Perseverance's genuinely impressive analytical capabilities, NASA scientists have consistently emphasized that truly resolving the Chiava Falls mystery will likely require physically returning the Sapphire Canyon sample to Earth, a complex multi-mission undertaking that NASA has been carefully planning for. Interestingly and importantly for keeping this discovery in proper scientific context, this isn't actually the very first time scientists have found evidence suggesting that ancient Mars may once have harbored the right conditions to support life. Throughout Perseverance's mission and throughout the decades-long history of NASA's earlier Mars rovers, including Curiosity, which has been exploring Gale Crater since 2012, scientists have steadily built up an increasingly detailed picture of a planet that, billions of years ago, looked dramatically different from the cold, dry, dusty world we observe today. Curiosity has previously detected long, complex organic molecules preserved within ancient Martian mudstone, chains containing up to 12 consecutive carbon atoms, among the longest and most structurally complex organic compounds ever confirmed on the Martian surface. Other studies have identified aluminum-rich clay minerals called kaolinite in rocks examined by Perseverance, minerals that, here on Earth, typically only form under very specific water-rich weathering conditions, and separate research has continued to build the case that Mars once hosted extensive underground water reservoirs, with a study published in March 2026 by researchers at New York University Abu Dhabi identifying new evidence suggesting that water didn't just exist on the ancient Martian surface, but actively moved and circulated beneath it as well, potentially creating exactly the kind of stable, long-lasting, water-rich subsurface environments where microbial life, if it ever existed on Mars, would have had the best possible chance of surviving and leaving behind detectable chemical traces. This growing body of evidence, ancient lake beds, long organic carbon chains, water-formed clay minerals, and now the leopard spots found within Chiava Falls, paints an increasingly detailed and increasingly compelling picture of early Mars as a planet that was, at least for some meaningful period of time roughly 3.5 billion years ago, genuinely habitable, at least by the standards scientists use when assessing whether an environment could plausibly support microbial life. This doesn't mean life definitely existed there, but it does mean the fundamental ingredients, liquid water, organic carbon, and the right kind of chemical energy sources that certain types of Earth microbes are known to exploit, were all apparently present simultaneously within Jezero Crater's ancient lakebed sediments at exactly the same time and place where these leopard spot biosignatures were later preserved. It's also worth exploring, at least briefly, exactly why some people have reacted to this discovery with a genuine sense of unease rather than pure scientific excitement, since headlines describing this as something terrifying beneath the Martian surface aren't purely sensationalized clickbait. There's a real, if somewhat philosophical, undercurrent of concern woven into how many people process news like this. For centuries, humanity has generally operated under the assumption, whether stated explicitly or simply, taken for granted, that life as we understand it is something uniquely and exclusively tied to Earth, a singular, precious, perhaps even miraculous occurrence, unlikely to be repeated anywhere else. Finding even tentative, still unconfirmed evidence that life, or at least the chemical precursors strongly associated with life, may have independently existed on a completely different planet, one right here within our own solar system, forces a genuine reconsideration of humanity's place within the broader universe. If life could plausibly have emerged on ancient Mars, entirely independently of life here on Earth, it raises the very real, sometimes unsettling possibility that life itself might not be nearly as rare or as special an occurrence as many people have long assumed, and that the universe at large, filled with billions upon billions of planets circling countless other stars, might actually be far more densely populated with biology, in one form or another, than we've ever previously dared to imagine. There is also a more grounded, practical dimension to this unease worth acknowledging directly. Confirming that microbial life once existed on Mars, even ancient, long-extinct microbial life, would carry serious implications for how future human missions to the Red Planet need to be planned and conducted. NASA and other space agencies maintain strict planetary protection guidelines, specifically designed to prevent biological contamination in both directions, protecting Mars from potential contamination by hardy Earth microbes that might hitch a ride aboard human spacecraft, while also protecting Earth from the remote but genuinely considered possibility of bringing back any kind of Martian biological material that could pose an unknown risk here at home. A confirmed biosignature discovery, even one pointing toward ancient, long-extinct microbial life rather than anything currently active, would likely intensify scrutiny and caution surrounding NASA's ongoing Mars sample return program, and would almost certainly influence how future crewed missions to Mars are eventually designed, equipped, and operated, adding a genuinely serious layer of biological safety consideration to what has, until now, been a mission focused primarily on geological and engineering challenges. It's worth emphasizing, though, that the scientific community's dominant emotional response to this discovery has been excitement and cautious optimism, not fear. Researchers who have spent entire careers searching for exactly this kind of evidence describe finding potential biosignatures like the leopard spots in Chiava Falls as one of the most rewarding possible outcomes their field of study could ever produce. Amy Williams, a researcher involved in related organic molecule studies on Mars, noted that discovering large, complex organic compounds preserved in Mars's shallow subsurface holds enormous promise for eventually finding even larger, more structurally complex organic material, the kind of material that might ultimately prove diagnostic of past biological activity, if such activity ever truly occurred on the Red Planet. This kind of measured, patient scientific optimism, genuine excitement tempered by rigorous caution about what remains unproven, characterizes how most researchers in this field have approached the Chiava Falls discovery, treating it as an important, exciting milestone along a much longer scientific journey rather than a final definitive answer to the age-old question of whether life exists or ever existed beyond Earth. It's also worth acknowledging the broader skepticism that some scientists outside the immediate Perseverance mission team have expressed regarding how quickly and confidently this discovery was publicly framed by NASA leadership. While the underlying Nature paper itself is carefully, conservatively worded, consistently describing the leopard spots as a potential biosignature requiring further study, some outside researchers have cautioned that public statements describing this as the closest we've ever come to discovering life on Mars risk, overstating the current state of scientific certainty, particularly given how many previous Mars discoveries throughout the decades, methane detections, formations resembling dried-up riverbeds, and various other tantalizing clues have generated similarly excited headlines before eventually being explained through purely geological, non-biological processes after more detailed follow-up analysis. This kind of healthy scientific skepticism isn't a rejection of the Chayava Falls findings. It's simply a reminder that the scientific process, particularly for a question as profound as whether life ever existed beyond Earth, demands an unusually high standard of evidence before any conclusion can be considered truly settled. A standard that, in this specific case, likely won't be fully met until the Sapphire Canyon sample is physically returned to Earth for direct laboratory study. Looking at the broader context surrounding NASA's other Mars-related discoveries over the past couple of years also helps put Chayava Falls into proper perspective. Separately, in late 2025, NASA's Mars Reconnaissance Orbiter revisited a long-debated mystery involving a suspected underground lake beneath Mars's south polar ice cap, first detected back in 2018 using radar data collected by the European Space Agency's Mars Express Orbiter. Using an enhanced radar technique, while this specific result didn't confirm the presence of an underground lake at that particular location, it demonstrated that this same enhanced radar technique could prove genuinely valuable for identifying other subsurface resources and features elsewhere across the Martian surface, potentially guiding future missions and future astronauts toward genuinely water-rich locations worth exploring in far greater detail. Meanwhile, Perseverance itself has continued its methodical, ongoing exploration of Jezero Crater and its surroundings, well beyond the initial Chayava Falls discovery, steadily building an increasingly detailed geological record of the region's ancient water-shaped history. By the end of 2025, Perseverance had traveled a total distance of nearly 40 kilometers across the Martian surface since its 2021 landing, surpassing the distance previously covered by the Curiosity rover, and putting it on pace to potentially break the all-time extraterrestrial driving distance record currently held by the earlier Opportunity rover sometime during 2026. Each additional mile traveled and each additional rock sample carefully studied along the way continues adding new pieces to the broader, still incomplete puzzle of exactly what conditions existed on ancient Mars, and whether those conditions ever truly crossed the threshold into supporting genuine biological activity. As we bring this video to a close, it's worth reflecting on just how remarkable it is that a six-wheeled robot operating autonomously on a planet nearly 140 million miles from Earth has potentially uncovered evidence of ancient biology preserved within a rock that's been sitting undisturbed for roughly 3.5 billion years, patiently waiting within an ancient Martian lakebed for humanity to finally develop the technology and the scientific understanding necessary to recognize its significance. Chayava Falls and the strange, colorful leopard spots hidden within it may ultimately turn out to represent nothing more than an unusually elegant example of purely non-biological Martian chemistry. A genuine, but entirely lifeless, geological curiosity. Or, if the Sapphire Canyon sample it produced is one day successfully returned to Earth and subjected to the full analytical power of modern laboratory science, it might instead turn out to represent humanity's first confirmed evidence that life, in some form, once existed somewhere beyond our own planet. A discovery that would fundamentally, permanently reshape our understanding of biology's place within the broader universe. Either way, this discovery represents genuine, careful, methodical science working exactly as it should, cautiously, rigorously, and honestly, refusing to claim more certainty than the evidence actually supports, while still recognizing and celebrating just how significant and how close this particular piece of evidence genuinely is. If you enjoyed learning about this incredible discovery, make sure to like this video, subscribe to the channel for more deep dives into space exploration and astrobiology, and let us know in the comments what you think. Do you believe the leopard spots on Chayava Falls are evidence of ancient Martian life, or do you think there's a purely chemical explanation still waiting to be found? We'll see you in the next video with another incredible story from the Red Planet and beyond.